Hello, everyone, and welcome to Build. I'm Wellington with the Azure IoT Device SDK team. Today, we're here to talk a little more about the device builder experience. I'm going to be covering a bit of the IoT devices, looking at categories of devices. Then we'll be looking at the Azure IoT Device SDK solutions for device builders. Then we'll be looking at what happens beyond SDKs. And finally, we'll close by looking at the SDK roadmaps. But let's start with categories of IoT devices. So when we're working with IoT devices, one of our initial concerns was to clearly define the categories of devices to create SDKs for, because that would be, we would like to create the SDKs that are the most appropriate for the category of devices they'll be used with. Here, as you can see, we have a number of devices going all the way from small 16-bit microcontrollers, going for a range of different 32-bit ones. Then we start seeing single board computers in here, like the Raspberry Pi or the Latte Panda here, and then going all the way up to Raspberry Pi compute modules or PCs, and yeah, even servers on a rack. They're all potential IoT devices. And the first way in which we can look at dividing these devices could be, say, let's look at their architecture. So if we divide like this, we would have this single PIC24 here as the 16-bit computer, and then going to all the 32 bits. And here we have a distinction between a bunch of microcontroller-based ones like the ESP32, ESP8266, some STM32, the NXP, going also again, right, to the Raspberry Pi and the Latte Pandas, and then going all the way up to the 64-bit computers. So looking at their architecture could be a way to categorize these devices. That's not the only one. We could also look at this distinction between microcontrollers, or all of these devices that are based on microcontrollers, going all the way to microprocessors. Another way to look at these could be maybe a category that can run bare metal, like all of these microcontroller-based ones, or a real-time operating system like Azure RTOS, FreeRTOS, and so many others, moving all the way to devices that will be running a full operating system, like Linux or Windows, or even custom OSs based on, say, Yocto Linux. But for us here at the device team, we are pretty much looking at a categorization that will look at these two main categories. The first one will be the sensor class category. And the sensor class is defined by being based on microcontrollers. They will be running bare metal or some sort of real-time operating system, Azure RTOS, FreeRTOS, as I said. And they will likely to be running something like C, C++. We're seeing more and more Python, the devices, microcontroller capable of running Python or some sort of assembly. And in the other hand, we have edge class devices that will likely to be running on a microprocessor, running on a full operating system or a custom operating system, and they will be using higher level languages, programming languages. So then the final picture will be something like this. Everything from the PIC24, which is again a 16-bit one, and before you ask for about 8-bit kind of microprocessors, so they could potentially run IoT devices, but it is, for the most of them, this is too much to ask. So we don't normally support them, or we don't have samples for them. 16-bit is really the minimum bar. These will all be the sensor class devices, and all of the other ones to the right here will be the edge class device. So this is important because our SDKs and your choices when connecting your devices to Azure IoT platform will likely to be aligned with one or the other. Let's take a look at what are the options when thinking about the device SDKs. Here in this slide, as you can see, we're aligning our options and our possibilities for device SDK based on that definition we just presented. So we have here under sensor class, we have the C, both the C and embedded C SDKs. We also have the Azure RTOS middleware. So this is a middleware that is also based on the embedded C, and it was made to enable Azure RTOS devices to be connected to Azure. We did the same with the free RTOS, which is also based on the embedded C, and it was made to allow free RTOS devices to get connected. And finally, we have the Arduino libraries, which would allow Arduino-based devices to get connected to Azure, also based on the embedded C SDK. And on the Edge class category of devices, then we'll start to see things like the C# or .NET SDK, we have the Java SDK, we have Python SDK, and we have the Node.js SDK. So when we're looking at all of these devices, you might be wondering, okay, but what is this SDK again? And in our definition of SDKs, SDKs is a set of samples, documentation, and the client libraries that will be used on the devices. And just in case you're wondering, so that's great, but why do I need a device SDK? Can I connect my device? So here's a device. Can I get this device connected to Azure directly without using an SDK? The answer is yes. All of the APIs for Azure IoT are public. They have documentation, and there's really nothing preventing you from doing that. However, when you take advantage of a device or a client library like this, you get the advantages of first, simplifying the connectivity, meaning that you get an SDK that would allow you to do that directly straight without having to worry about what are the APIs involved or how to call these APIs. Things like provisioning and authentication are part of these client libraries. You get support from Microsoft for all of these SDKs. Every time there's a new feature, we're going to be adding these features to the SDKs, so you get always the latest and greatest from Azure. There is an important component of cost savings in terms of, first, the bill of materials. When you have the need for less memory, for less CPU power to run your devices, so that makes it cost less. And also because when you are leveraging one of these SDKs, so there's hundreds of investment in engineering hours to create these SDKs that you taking the advantage of the SDK won't have to do. So it will save you development money. And also, it allows for a faster development because these SDKs are provided with samples, they're provided with documentation that you can take advantage of, and it will likely to shorten the time to get your product to market. But these SDKs, they go way beyond, as we can see here in this picture. We're looking at the client library, but they go way beyond that. As we can see here, these SDKs, they're not only providing the client libs, as we can see here on code, the client library with the tests or code snippets and the samples or examples for all of this code. There's much more. There's guidance in terms of the documents showing what to do. There's documents showing how to do things, how to do porting or porting guidance and things like that. There's also supporting material that would help both getting your device connected and all of the internals for that device, but also the external on how to leverage all of the IoT services from Microsoft. There are tools in terms of helping with code generator, diagnostic tools, simulators, simulator tools as well. And this is all to help you customers to help the engagement with the community, engagement with our teams, also to get connected to our community via blogs and video and things like that. And there's a number of other ways in which we can get connected to customers leveraging our SDKs. And there's also the fact that when we look at the future of where these SDKs are going, one of the things we do a lot is to hear your feedback and get your feedback about what's working, what's not working. Which leads me to this next point, which is looking at the next generation of our SDKs. So let's take a closer look at this. So currently, what we have is the generation 1 SDKs. They are built to support all MQTT, AMQP, and HTTPS. They pretty much bring their own MQTT client. We call that hard-coded because it's hard to change that for another client library if you don't like the one we have. Same goes for networking. And because we are bringing all of these capabilities to have all support for all MQTT, AMQP, and HTTPS, changing them might be complicated, right? Also, they tend, because we have all of these internal layers, getting error codes might be a little cumbersome. And finally, the feature set is not consistent across all of the different languages. Now, when we look here at what's going to be with the generation 2, that's a completely different approach, in which here you can see we're going to be focusing on MQTT as this standard approach to get devices connected. We are bringing this bring your own MQTT client for lift and shift scenarios, not only for that, but also for the networking for embedded systems. So you get here a bring your own network stack, MQTT, TLS, and socket. These are all choices customers will have with generation 2. They are flexible and layered. They will surface all of these IoT Hub error codes for easy to use and reconnect and to treat these errors if that's the case. And finally, these SDKs would be functional equivalent, but they were still maintaining their language style, which means that even though across the SDKs, the functionalities will be there, we're still understanding and respecting the fact that when you create something in C, it should look and behave like a C application, and same goes for C# and same goes to Java. And this is not only the plan for the future, but this is already a reality for some of the SDKs. So when we're looking at what are the SDKs generation 1 that are alive, so these are all of the options: C, Java, .NET, Node, and Python. And when we look at what is next generation or generation 2 of the SDKs, actually, we already have a set of SDKs that are in this generation 2 already. So we have the embedded CSDK, the Azure RTOS middleware, we have the free RTOS middleware, and the Arduino libraries. All of them already have these benefits that I was talking about, specifically about the bring your own network stack. And we are in design phase to bring not only the C based SDKs, but all of the other SDKs also to generation 2. Right now, they are in design phase, so we don't have a date for this yet, but this is where the Azure Device SDKs are headed for. So finally, let's take a look at the Device SDK's feature roadmap. And here we have a bunch of things that we are doing for all of the different SDKs. As you can see here, we start by looking at the built-in PNP or plug and play support for the .NET SDK, which is already being released as per February. Same goes for the Java SDK with the version 2. There's a major release. This has been released as per last week. And then coming on, a long-term support release for Python. This is also for April. And then for the Arduino libraries, we are bringing samples for additional dev kits. Right now, we have samples for Arduino-based devices, but we don't have any for an Arduino official boards. We will be doing that soon, bringing a couple of official Arduino boards. Then on May, we should be bringing cellular samples. So samples showing how to get free RTOS-based devices connected to Azure using cellular connectivity. And then comes June, we're going to be building in public preview DPS X509 cert management tools for both the Python and .NET SDKs. Then July 2022, also in public preview, we should have the over-the-air capabilities leveraging Azure Device Update for both embedded C and free RTOS middleware, which means that small devices will be able to have this over-the-air update capability natively from the SDKs. And then finally, looking at July 2022, we should have a long-term support release for the CSDK and also the native PNP API support as well. So as you can see, there's a lot we're doing. There's a lot more to come on the Azure IoT device SDKs. As I said before, we have this distinction between small constrained devices, and we have this whole set of bigger devices. We are creating SDKs that would help you get your device connected to Azure, regardless of its architecture, its size, memory, capacity, and things like that. And we have a roadmap packed with features that will help you get your devices connected. So please take a look at our SDKs. If you have questions, if you have comments, we're always happy to engage with you. There's always, if you find anything that's not working well for you, please log an issue in our GitHub repositories. Please also keep in mind that all of the SDKs and everything we showed you here is open source and free to use, free to modify, free to adjust to whatever specific need you have for your devices. So take a look at those, take a look at our SDKs, see how much they can improve your development cycle, how can they help you accelerate the development of your solutions to get connected to Azure IoT. And as always, if you have any comments, questions, please get in touch. That's it for now. Take care.